Welcome to the channel. In this tutorial, we will explore two powerful ways to insert mathematical symbols, specifically Greek letters, into your graphs using Gnuplot. In addition, I will show you how to use two very useful terminals, 𝑮𝒐𝒐𝒕 and tikz, to generate graphs with mathematical symbols in an efficient and personalized way. This knowledge will be useful for anyone looking to improve the aesthetics and readability of their graphs.
Let's start with the pngcairo terminal, which outputs a .png image and has more customization options thanks to the included pngcairo library. In line 1, we set the terminal with the dashed enhanced option, which provides flexibility when creating graphs with different line styles and with improved visual quality. We also set the image size to 600 x 400, Arial font 12 and scale 1. In line 2, we set the name of the output file. In line 7, we set the UTF-8 encoding, which is essential to ensure that special characters, accents and other symbols from different languages are displayed correctly in your graphs. Then, in line 9, we set the horizontal x-axis label inside the quotes. Notice that there is the use of curly braces and a slash for the term symbol G. The reason for this is in this guide to symbols produced by Dick Crawford. Notice that in the first line he shows how to write superscript and subscript. Scrolling down a little in this material, we see how he writes the symbol pi in the same way as in our script. On the second page of this guide we see a conversion table with the numeric code, the text input T and the symbol S that will be produced if you write that syntax replacing the appropriate letter. For example, to produce the Greek letter alpha, simply place the lowercase letter after symbol and inside the curly braces. So this explains the use of the syntax found in our Gnuplot script. Still on the same line, we define the subscript 1 in J. To generate our graph, run the command gnuplot ptemplate.gnu in the terminal. The PNG image will be generated at the same directory level as the terminal. This means that we can have a collection of templates inside a folder, and run the script outside the folder, and the plot will also be generated outside. Note that we have the Greek letter gamma on the x-axis. It worked. However, it is a little different from what we find in texts generated from latex. In addition, we are hostage to the symbol conversion table, which I will leave a repository on GitHub with the link here in the description. What if we could use latex code directly in our script and the output was a vectorized drawing such as PDF, EPS or SVG? Well, this already exists, but we will have to use another terminal. The latex language is well known for generating text with great typographic quality, especially for the use of symbols and mathematical equations, but it is also possible to use it to produce graphs and diagrams through the tikz library. And this is how we will generate our PDF graph in LaTeX Standard. We commented out the lines of code related to the pngcairo case, and in line 4 we defined the tikz terminal. We commented out the lines of code related to the pngcairo case, and in line 4 we defined the tikz terminal. I must remember that there are many other terminals with specific uses, and this is not the only terminal capable of generating PDFs, but it is the best and most versatile one I have found so far. Still on line 1, we define the general thickness of the graph lines with lin width equal to 1, and we will use the standalone style, which defines that the PDF will not be in a 4 format, but will be customized to suit the drawing, since we do not want to have to crop the generated image yet. Then on line 5 we define the output file, in a similar way to the previous case. On line 12 we define the x-axis label, but now the syntax is a little different from the PNG case. In LaTeX, to define that we are in mathematical mode, we enclose the expression with the dollar symbol and use a backslash for LaTeX commands, such as to write a Greek letter. There are more details of LaTeX syntax for other cases. We will restrict ourselves here to this one only. Here we use 2 backslashes instead of a single backslash. The rest remains identical, as if we were in a LaTeX text. In line 13 we define the vertical axis, and in line 15 nothing changes. We use the same command as before to run the script, but now the output file is not the finished plot, but a .tex file. We can open this LaTeX file and modify it, include other packages and edit the drawing. We will still have to compile it with a LaTeX compiler. This can be done directly in the terminal with pdflatex followed by the name of the file with the .tex extension. We notice in our directory that several files were generated, among them the PDF with our graph, which is similar to the PNG case, but prettier and with the gamma symbol as we find in mathematical texts. Another option, instead of compiling directly in the terminal, is to open this file in a LaTeX editor and compile it there. The result will be the same, but be careful with the choice of LaTeX compiler. We have two approaches available to use, with their advantages and disadvantages. With pngcairo, we have a quick and simple solution, but the output cannot be used for scientific articles, which usually require figures in EPS format. In other words, we have ease of use and wide compatibility. But if you want more mathematical resources and the possibility of using them for publication in journals, since the generated PDF can be easily converted to APs, tikz is a good option with highly customized graphics and the quality of LaTeX. In other words, greater flexibility, customization and integration with the LaTeX ecosystem. Did you like this content? Subscribe to the channel and leave comments with questions or suggestions for future content.